problem number 23 from 3.1 of the book. And I'm going to read the problem, even though it's printed right there. It might be hard to read. It says, the graphs in figure 310a, these two graphs, show the numbers of rabbits and foxes, well, 310a, that would be this graph here, the number of rabbits and foxes in a small Arctic population. And they are plotted as functions of time for 200 days. So, for example, on day 50, the number of rabbits looks to be about 2,000. Or on day 100, the number of rabbits seems to be closer to 200. So it's basically time on the x-axis and number of rabbits on the y-axis. And you can also see it says we started out with initial number of rabbits on day 0 of 1,000. So that kind of explains what graph A is. The graph is telling us that the number of rabbits increases at first as the rabbits reproduce. But then the foxes start eating the rabbits. And as the number of foxes increase, you see the number of foxes is increasing right there. Even while the number of rabbits kind of levels off and then starts declining. So the graph of B down here is showing us the slope of the tangent line of graph A. In other words, what is the rate at which the rabbits are increasing or decreasing? Let's see if we can make some sense of that. Now, one thing to notice is that the graph of my derivative has my 0 right in the middle here. So, as I'm looking at my graph of the number of rabbits, the number of rabbits is increasing from day 0 to day 20. And if you look at that segment that I just drew in blue up here, you can see that actually the slope of the tangent is actually getting more steep. Not by a lot, but by some. It is getting more steep. So the slope of the tangent line is actually going from here, and it's going upwards. Now, right about this point here at 20 days, the slope of the tangent line, while it is still positive, it starts changing so that it's starting to get more negative. It's actually starting to get closer to 0. So the slope of the tangent line, while still positive, is actually decreasing. It's getting less and less positive. It's getting to be a smaller and smaller number. And so right there at that point, I have the slope of my tangent line is 0. The slope of my tangent line is 0. This point by the way, right there where it starts changing from the tangent line becoming more positive to it becoming less positive, that is called an inflection point. And we'll get into that later on in this chapter. But for now, let's just work with the derivative. So I can see that from this point here, the rate of rabbits is starting to decrease very dramatically. The slope of this line, the rate of change of this line is very steep. So I'm losing a lot of rabbits every day. My rate of change in the number of rabbits every day is decreasing. And I can see that here. This is describing the slope of my tangent line. And you can see it's very negative, and it's getting more and more and more negative. Until right about this point here, same place I am there on the upper graph, even though the number of rabbits is decreasing, the slope of my tangent line is starting to get a little bit less negative. It's still negative, the slope of my tangent line, but it's getting less and less negative. It's starting to even out. So you can see that right here. The slope of my tangent line is still negative, but it's starting to even out. And as like from day 100 on to day 200, you can see that my rabbit population is pretty much evened out. It's hard to tell from this graph here whether this tangent line is right at 0, where my rate of change is nothing, meaning my rabbit population is just staying the same, or whether it's still a little bit negative. It's hard for me to tell. But whatever the case, even if it's just a little bit negative, you can see that the rate of change of my rabbit population isn't very much. And when that happens, the actual rabbit population is also not changing very much. So again, it's kind of the relationship between the function graph and the derivative. So now let's take a look at the questions. Question A says, what is the value of the derivative of the rabbit population in figure 310 when the number of rabbits is largest? Well, the number of rabbits is largest right there. And what is the slope of the tangent line right there? Well, the slope of the tangent line right there is 0, because I have gotten, the rabbit population has been going up, and it reaches its maximum, and then it starts going down. So the slope of the tangent line right at that maximum is 0, and that corresponds with the 0 right there on the graph of the value of the tangent line, the value of the derivative. How about when the rabbit population is the smallest? Well, it's hard to say again. This might be continually declining, but let's say that its smallest is right about there, and again, the value of the derivative is 0, because that is a minimum. You know, the graph can't go down much more. I guess if it went down much more, I would then have like more of a negative slope. But in this case here, the minimum where the rabbits are is also a 0 point of the derivative. To answer question B, where the derivative is the largest, well, that corresponds to the point right here where the inflection point is. In other words, that is the point where the rate of change of the rabbit population, where the rabbit population is growing the fastest. The number of rabbits that are being produced is still growing after that point, but the rate at which they are growing is declining. This is a difficult concept. You got to think about it a little bit. I can have the number of rabbits growing, but maybe instead of growing at 50 per day, they're only growing at 30 per day. Well, that's why the derivative is going down from 50 back down to 0. And similarly, where the derivative is the lowest, that corresponds to this point right there. So the rabbit population was undergoing this terribly steep decline. I mean, they were just getting eaten by foxes like crazy. And then, although still in decline, they were not declining as fast. And so eventually they actually began to level off. So again, it's something to think about, this relationship between the graph of the function and the graph of the derivative. And this is a nice example to kind of go back to see if you can understand how it works in real life situations.